But now, the last presentation before the coffee break is Bologna digital twin, building the geometrical model. Speaker Chiara della Casa and Mirko Degli Esposti.
Great, thank you very much.
Thank
Thanks
you.
to the organizer. I have to bring you to the coffee break, so I hope not to be too boring. But I'm very excited for what I heard before. It is not formality. I'm going to tell you, especially the colleague from Helsinki, for Vilnius. Chiara, I'm not Chiara, I'm Mirko. Chiara was supposed to be here, but she had a small accident, so she's in Italy, and I have to give also all the talk. So I'm sorry for that, but I hope you can support me for a few minutes. I want to tell you what we are doing in Bologna on a very specific topic. I'm a physicist, together with the group at Cineca, about building a geometrical and physical model, as is written here, is inside a bigger project of a digital twin. I will just say a few words. Let me anticipate that, as you will see, in some aspect we are very well beyond Tallinn, Vilnius, and Helsinki, but this is not a race, or at least it's a very long race, so I hope we can work together and bring something that you are doing north of Europe to the south of Europe, if you don't mind. So what I'm going to talk, was supposed to be the part of Chiara, is inside a bigger project. The colleague of Tallinna already know because they were in Bologna last year. It's a project run by the municipality with the participation of the university, Cineca, which is a supercomputing center. This is basically something which belongs to the municipality, and also is the project it's coordinated by research center, Fondazione Bruno Kessler, which is in north of Italy, in Trento. It's a digital twin of a city to do or to achieve the objective that we all already know very well here. I'm not going to say what is my definition of digital twin, because it's going to be different from yours. So let's move forward to some concrete application or result. And of course, what we want to do, we want to implement analysis and forecast, and everything that I'm not going to read because I'm sure that you know very well. And it's a public consortium run by the 5 members that I've been already told you. The leader is a municipality of Bologna. So it's a municipality, and this is not so common in Italy, where usually these projects start from university or from the private sector. So this is very interesting. We are well beyond Helsinki because we started basically 223, thinking about then 224, so it's a long run, so we just started, and you will see that in fact we are quite beyond. But this can be nice, right? Because when you are beyond, you can try to run faster and get advantage of a more mature colleague and experience around you. So I really hope that we can bring, and I will be very specific at the end, especially about the green, urban green. I really hope that we can cope and collaborate together, because I think, but I will discuss this at the end. Of course, we have some domain where we concentrate. I'm sure they're not a surprise for you, which are the mobility, the energy, and the climate change. And I'm sure this is not a surprise. It's quite obvious, but we are doing this very, very seriously. And I'm not going to read everything on the slide here, but you can understand Bologna is one of the 100 cities for the neutrality. And these are the best. And the 1/4 topic, of course, it's the green one. So there is a multidisciplinary group made from the supercomputing center with data analysts, civil engineering, expert in artificial intelligence, expert in HPC, which are here also, together with the group in the City Science Lab, which is a group at the physics department. I guess we have a gender issue, but that's not something I want to discuss here. We will try to solve it in the future, but it's something it's there, I don't know what to say. And together with the group at the Cineca, we are working together in building, trying to build a geometric and physical model of the city of Bologna inside the bigger project of a digital twin. And I will focus on the first objective. So the first one is incremental building of a geometrical and physical model of Bologna. Why we want to do this? Well, of course, because we want to support some vertical application, which is already ongoing in the project. One is about building an urban energy model of a city. A second one is a specific group of people which have some objective in mobility, as I said. And the other one, I will tell you at the end, is something what I call green and roof. And I will be more specific in a second about what we are doing. So in order to support this vertical application, we want to build a geometric and physical model. We do in an incremental way. And as I will tell you, and then we have a second objective, which I think is very important. We want to developing tool to improve urban data quality. So probably this is for you something very traditional and old, but for us it's new. So we are extracting, as I will see very specifically in a few minutes, some information from geodata. We are using, last powerful tool on artificial intelligence to extract and to get some more semantic information about the city. And in doing this, we are going back to develop some useful tool and improve the quality of the urban data for the people working at the municipality and then for the citizen. The citizens are one of the major objects and very, very important in the project, but I'm a mathematician, so I will not talk about citizens today. But of course, they are very important in the whole project. But I will not talk about this. I will talk about how we perform this way, going from the data we have to some semantic information about the city. And again, probably Tallinn and Lithuania and Helsinki already have done this, but I would like to share you what we have been done recently. Methodology, we have an incremental approach, which is something that probably for you it's very common, but in Italy it's not. Usually in Italy, in the city, you have a European project. They develop a beautiful result, an algorithm, and data structure, and data lake, and whatever. And then at the end of the project goes into the closet. Everyone forget about the project. Everyone forget about the result. Then the next group come and start from the beginning. In Italy, we like to do like that. But I'm sure not only in Italy, but we try to avoid this. So we try to do really incremental, not to throw away everything that we have done, but to build. I know that for some of you this is probably silly, it's probably trivial, but I think it's very important. The second thing is that I said what I call no benchmarking obsession. So we are not looking for the best algorithm to beat the world, because we are not able to do it, but we want to do the best algorithm to fit to our data, which are very, very specific. Of course, they are very common as a urban data, but I'm sure that in Bologna we have some specificity that we want to strengthen, we want to use. So we don't have the obsession of benchmarking. And of course, and this is an incremental approach. So let me see for what we start. Again, we have some data. What we are going to do today, of course, the project has different aspects. Today I want to talk about the data we have. In particular, we have LIDAR data or LIDAR data. I'm sure that Helsinki, Tallinn, and Lithuania have a long tradition on that. Bologna has 20 here of orthophoto and oblique orthophoto data, but we have only 2 here of LIDAR data. So for us are quite new. You know, it's a very mature technology, but also very innovative, because algorithms are needed also for other applications outside urban, like self-driving. So to have an idea, we have an annual airborne campaign on the city, and we have a lot of data which come from with a digital terrain model and digital surface model, but for some of you, this is quite. But this is what I'm going to talk today. No one never analyzed, and we want to extract as much information as we can from the LIDAR data using the specificity of the territory of the city of Bologna. Let me say that Bologna, just technical, Bologna is divided in more than 654 tiles of 50 by 100 meters. Each one of these is a tile. Here is one of the 600 tiles. We have billions, 3 billions of cloud points. They come with some ground and on-ground and some spectral data taken from the orthophoto, like the near value, which is quite good for vegetation. As all of you know, they have multiple return at about 25 points square meter in the average. So these are the data I want to talk about. I want to discuss what we did very, very recently. And we also have other data, as usual. We have data which have been built during time from the city of Bologna, which is still in the open data, which are data about the infrastructure. Sorry, how I go back? Here, data is about the infrastructure. We have data, of course, about the road network, and also we have public, incomplete, stratified over time data about the low, medium, and high vegetation. So this is our starting point. We are late, probably we are late, but we started from here. And so the first thing that we wanted, what we prefer at the urban level, so at the level of a city, is something that probably you already done, but is a first semantic segmentation of a city. And we try to do it with the most modern tool we can have our end. So this is, I'm going to explain you. We start from the cloud point, we did some segmentation, and then we did some labeling to look at the city from above and find out and be able to extract different semantic objects, different objects from this data. We did it first in a very traditional way. We have this billion of points. We calculate for each point some feature. So people who are interested, I can tell you the details. This is very, very classical in the literature, but we did it on the whole city, and we were able to describe the local geometry of this point. But this is not very interesting. What we did is that we use SAM, which is called segment anything model, which you probably know, but it's quite recent. Actually, it's been, this is a paper, I think one of the first one where this segmentation, this vision fundamental model has been used to orthophoto or to LIDAR data. I just want to point out that it's a very, very recent approach. The segment anything, probably all of you know, is a vision model by Meta-AI. It's based on transformer. It has been trained on billions of image and captions, so it's able to do zero shotting. It's able to generalize, so it's able to analyze also pictures that have never been seen before. To be more technical, we didn't use SAM, we used something even more recently with some LIDAR. So we are able to segment directly the LIDAR data point. So we got the first segmentation of the few tiles, and we use this segmentation to label the tile. I'm not going into the detail now, but I will be very, very happy to do it if someone is interested. And then we use this label to train some artificial intelligence model. The first one is quite traditional because it's a random forest, so it's a very old machine learning technique. But with this, we were able to do inference. So we take the LIDAR data, we do segmentation, we segment, we do the train for few 2 or 3 tiles, and then we train random forest to do this on Bologna. Probably you have been done this on your city for a long time, but this is the first time that has been done on Bologna. And what I think is interesting, that thanks to Leonardo and the supercomputing center we have in Bologna, and thanks to the people who knows how to parallelize algorithm, we were able to do a semantic segmentation at the urban scale all over the 656 tile. It just takes a few minutes now, And we were able to do this all over the city of Bologna. And then you ask me why? Well, first of all, because I can come here and tell you, which is already fine, but I will tell you exactly why we are doing that. And it's never been done before in Bologna, so we believe that we want to extract as much information as we can from the data we have. We also have a fusion technique using orthophoto, using the data we have for open data. I'm not going to talk now, I just want to give you an idea of what we are doing in this case. Then we are doing things because, you know, now with this large model, you can look at the city and use even language, natural language to extract objects. Don't look at the picture because they are wrong, because I forgot to put the final one, which was just the first one. But basically, we are using leader point, we project in two-dimensional, and then we use the capacity of a large language model to extract object from the picture by using language, natural language. And we think that this is quite exciting. I mean, it can also be useful to build up interface for the citizen and so on, but also to extract useful information. And we are using something which is some geo, which I already quoted before, and some leader to work on leader points. So we are looking at the city with above, also using natural language, a fundamental model. We are doing, because we like to say we are using some other more recent tool, training convolutional network, or we have point net approach to the cloud. I'm not going to this, but we are doing all we can to start from the data we have and extract information about the city. Why we do this? Oh, well, first of all, to build some more realistic model, again, in incremental approach, we had a mesh model, and now we can move to something more realistic. This is made by the Visit Lab, which is a visual information technology lab at Cineca. This is just a video, I can tell you more, but we use this information to construct the next 3D model of Bologna. We also use this semantic segmentation, which is able, as you can imagine, to extract, as you know better than me, to extract building, vegetation, and other objects in a very quite powerful way. Again, this is something that probably you have done, but it has never been done in the city of Bologna before a few months ago, and now we can go at the urban scale. We extract roof. Bologna has quite complicated, especially the medieval part, complicated roof structure. And we are improving the way of extracting the shape, the inclination, and all the geometrical data regarding the roof, because of course they are very important, the energy model, solar assessment, and so on and so forth. And so this is 3D semantic segmentation, roof extraction, and this, everything I said now, it has been done. It has been done in the last 6 months. Of course, we need to improve it, and this is why I'm here. I hope that something can be useful. We like the modern approach with the recent tool of artificial intelligence to extract information at all. Something that I think we are well beyond, but it's something that we want to do. And this is also, I like very the talk of a colleague from Vilnius and from Tallinna and also from Helsinki. Is it green? This is in progress because with the data we have, with this density and multiple return and orthophoto and the open data from the low, medium, and high vegetation, for sure we can calculate something. I'm sure we can, I have the idea that we have data to calculate some, well, I don't know, I'm not sure about individual tree segmentation, but for sure we can capture the properties which tell us about the trees, the single tree, even if up to now we have only one campaign, one every year. So I know very well the limitation of that. Of course, we can calculate the, well, we already did the sky view factor, not only because it's nice, because together with vegetation index, which now we can calculate, before we could not, we can build up, together with the climate and temperature data, we can do something about the urban heat island effect. And so this is something that we are here. Now, I was talking with some Italian expert on urban digital twin, and they told me that in Italy, the green and a urban green is not the first priority, is not the second priority, it's probably the third priority. I'm not sure. Bologna put this urban green, even to build a better inventory, as one of the main goals for 2030. And I like usually in Italy to think against the public opinion. So I think it's the right time also for an Italian city to face the capacity that we have to extract information from our data about the green infrastructure interaction and how the urban green can be monitored, can be predicted, can be useful for achieving some sustainable goal of the city. I think, well, not I think, I mean, it's evident that we are very beyond what we are doing in Estonia, in Lithuania, and in Helsinki. But this is why I'm here, so I hope we can interact and collaborate. And visiting a city in the north of Italy is always nice. Bologna is not so bad. So I hope we can really collaborate. But this is what we are now. So again, I only focus today on a very specific part of the whole project of the Bologna digital twin. And of course, I concentrated on the small things that I know. But of course, there are people working on other things, and citizen engagement, and all the other very beautiful aspects of a digital twin. For now, we just put our whole effort to use the most advanced algorithm to extract geometrical and physical information from the data we have. Today, I just show you the few small results we had out of LiDAR data, but of course, we are also working on orthophoto and other kind of data. And most important, we are crossing that with the data we have from the open data. Of course, we have, as you know, the shape file of all the building, but also this shape file of all the building are data which has been stratified by time, by human. And thanks God, human make a lot of mistake. So now we can try to work and correct this mistake. And I think that the combination of nowadays algorithm with the data we have, I didn't talk about the satellite data because they are supposed to arrive. Now we have only airborne LiDAR data one every year, and we try all the best to exploit and extract information. If I said just one thing that is interesting or useful for you, I will be very, very happy to interact. And by the way, I thank you a lot. And you should thank me because I save 5 minutes and we can have 5 more minutes for coffee. Thank you very much for your attention.